In this video, we'll start simplifying expressions with negative exponents, and we will need negative exponent rule. If the negative exponent is on the numerator, that means dividing 1 by x that many times. So it's 1 divided by x, changing the power to positive. So that rule is giving us the chance of changing the exponent to positive. If the exponent is negative on the numerator, we put 1 over and change the power to positive. Today the focus will be mostly on the product of powers. If you have to multiply two powers with the same base, we keep the base and add the exponents. And then the next lesson I'll use the power of power. So today the focus will be on these two rules, the negative exponent rule and the product of power rule. We're going to simplify expressions and make sure that all the answers will have positive exponents only. So in our answer in a simplified expression, we must have only positive exponents. For each example, we are going to use the rules to simplify, make sure we have the answer with positive exponents, and some expressions can be evaluated further to standard form. I'll show you exactly what that means. So for the first example, I have the base a to the third power multiplied by the base a to the negative fifth. So we have two powers, one with positive, one with negative exponent. The product of power rule says keep the base and add the exponents, so 3 plus negative 5. Using the integer rules, that would be a to the negative 2. 3 plus negative 5 will be negative 2. I cannot record this as a final answer because in my answer I must have only positive exponents. So that's when we use our negative exponent rule to change that to positive. So if the base is to the negative exponent on the numerator, so I put it over 1 to make sure we can understand that the numerator is the whole number. Over 1 it looks like a fraction. And then we are dividing 1 by a to the second power. That will be your answer containing positive exponents only. Since this is a variable expression, we can't go on to standard form because we don't know the value of a. So this becomes your final answer, 1 over a to the second power. Let's see another example. N to the negative 2 multiplied by n to the negative 4. Product of power rules say keep the base and add the exponents. Negative 2 plus negative 4. Adding two negatives, it's negative 6. And this is the answer that contains negative exponents. So we're combining the negative exponents, we're adding them, and this answer has negative exponents. So we have to go further, use the negative exponent rule to change it to positive. So that will be 1 over n to positive 6. And since we don't know the value of n, we stop there. We have the simplified expression and we have positive exponents in the answer. B to the sixth multiplied by b to the negative third. Product of powers rule says keep the base and add the exponents. So 6 plus negative 3 will be b to the third. This is already a simplified expression that has positive exponents, so we don't have anything else to do. That is it, the final answer. Simplified expression has positive exponents. X to the third times x to the negative fourth times x to the second. We have x is the base. The rule says keep the base and add the exponents, so 3 plus negative 4 plus 2. First, we'll want to simplify 3 plus negative 4, so that will be x to the negative 1 plus 2. Then negative 1 plus 2 is 1, so that would be x to the first, or just x. And that is already a positive exponent, so there is nothing else that we need to do. When it comes to numbers, however, if the bases are numbers, we use the same rule to start with. Keep the 4, add the exponents. If the exponent is not shown, it's always 1. So 4 multiplied by itself once, that's 4 to the first. And then plus -3, because the product of powers rule says keep the base, add the exponents. 1 plus -3 is -2, so it'll be 4 to the -2. Now, this is not your final answer because all the answers have to have positive exponents. That means we use the negative exponent rule and we put 1 divided by 4 to the second power. Now, this could be the answer in an exponential form evaluated further, because we can solve 4 to the second power. 4 times 4 is 16. So this is called standard form, when we can actually solve further. So 1 over 4 to the second power is 1 over 4 times 4, which is 1/16. So the answer containing positive exponents is an answer in exponential form, and then that can be solved and to standard form. 2 to the -7th multiplied by 2 to the second. We'll be keeping the base, and -7 plus 2, add the exponents using the product of powers rule. Then -7 plus 2 is -5. We have to change this into a positive. That means 1 over 2 to the 5th. And 2 to the 5th is 2 times 2 times 2 times 2 times 2 times 2. So we can simplify, or actually evaluate further, which will be 1 over 32. So 2 times 2 times 2 times 2 times 2. 1 over 2 to the 5th power is the answer in exponential form. 1 over 32 is standard form. 5 to the -2nd multiplied by 5 to the 5th. We'll keep the base and add the exponents, where -2 plus 5 is 3. And this is an answer already that has positive exponents, so there is no change to be done. It's 5 to the 3rd, the simplified expression with positive exponents, but we do have the ability of multiply 5 times 5 times 5, which will be 125. So this answer is standard form. Exponential with positive exponent, standard, multiplied all the way. When it comes to negative bases, same rules apply. -3 to the -2 and -3 to the 4th. We have keep the base, -3, and -2 plus 4. We'll add the exponents. So we keep our base, -3. We add -2 plus 4, which is 2. That is an answer that has a positive exponent, so -3 to the 2nd power is a positive exponent, which is good. No changes need to be done, but we can multiply -3 times -3, and that will be a standard form of the answer, which is 9, positive. Let's see another base that is negative. In the base, we have -2. The exponent is -6. Multiplied by the same base, -2, the exponent is 3. So we keep the base, -2, and then -6 plus 3 we add. We keep the base and add the exponents. -2 is the base. -6 plus 3 equals -3. Now, this answer is exponential form, but it has negative exponent. So we need to make sure that we change that to positive. So again, we keep the base and change the exponent to positive. That would be 1 over negative 2. So we keep the base, but we change the exponent to positive. That means what we have here is 1 over negative 2 times negative 2 times negative 2. So this is my negative 2 to the third power positive, because I can multiply negative 2 by itself 3 times. And the standard form will be 1 over negative 8, because 2 times 2, 4, negative times negative is positive, but times the third negative will be negative 8. So 1 over negative 8, or negative 1/8 as the value of the fraction. And one more example with 3 numerical bases. The rules are exactly the same. If you have a product of 3 identical bases, we keep the base and we add the exponents. So negative 2 plus 5 and then plus negative 1. First two numbers first. I have keep the base, negative 2 plus 5 will be 3. And then plus negative 1, that will be keep the base 3. 3 plus negative 1 is 2. That is an answer that has already a positive exponent. So the simplified exponential expression will be 3 to the second. Multiplied 3 times 3 will be 9. Standard form.